So what's the deal with this dot product business? What's it even used for? Okay, well, that's what we're going to talk about now. The dot product is used to find the angle between two vectors. If u and v are two non-zero vectors, the angle theta, where theta is between 0 degrees and 180 degrees between the two vectors u and v, is determined by the following formula. The cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. Okay, that's why the dot product is so important. Okay, because if you have two vectors, you can use this formula right here to figure out the angle between the two vectors. So let's try it in example 9. Find the angle theta between u equals 4i minus 3j and the vector v, which equals 2i plus 5j. Round your angle to 2 decimal places as necessary. Okay, so I have provided a grid. It's not necessary to sketch this out, but I do want to show you just to get an idea. If you sketch your vectors, you can have an idea going in whether you should be calculating an acute angle, an obtuse angle, or a straight angle, or a right angle. You have an idea of what to expect for your answer. Okay, so when I look at this, the vector u in component form is 4, -3. Okay, so I'm going to go and sketch that out. It is a position vector. Its initial point will be at the origin, and then its terminal point will be at 4, -3. Okay, so that's going to be right here. Okay, so I'm going to draw my arrow. It's going to go from the initial point to the terminal point. It's going to look like this. Okay, so this is vector u. And then I'm going to draw out vector v. I'll put that in a different color. Okay, in component form, it's 2, 5. Okay, so we have another position vector. So it starts at the origin, and then its terminal point will be at the point 2, 5, which is right here. So I will draw from the initial point to the terminal point. Okay, and this is what vector v is. Okay, we're trying to find the angle between these two vectors. Okay, so right here, this is going to be theta. Okay, so if you just look at this angle that I've labeled theta, okay, if you might have to turn your head. I'm turning my head so that the vector u is horizontal. So it's looking like it's just over 90 degrees. Okay, so that's what I'm going to expect, an obtuse angle closer to 90 degrees. Okay, so to figure out what this angle theta measures, we're going to use our formula that we just saw in the box. The cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. Okay, that's what the formula is. Okay, so we need to do some calculations before we plug into this. We've got to figure out the dot product. We also need to figure out the magnitude of u and the magnitude of v. Okay, so let's figure this stuff out. Okay, I'm going to go out to the side and I'm going to do u dot v. Okay, so I need to take the horizontal components and multiply those guys together. So this is going to be 4 times 2. And then I need to take the vertical components and multiply them together. So this is going to be -3 times 5. Add the results. Okay, so this is going to be 8 minus 15. The dot product is going to be -7. Okay. All right, now I need the magnitude of u. Okay, so remember, how do you find the magnitude of a vector? Okay, I'll write right here, I'll just use a generic w. Okay, the magnitude of vector w, it is going to be the horizontal component squared plus the vertical component squared, and then you add the two squares, and then you take the square root of the result. Okay, so here the magnitude of u is going to be the square root of, underneath the square root sign, we're going to square the horizontal component, we're going to square the vertical component, we're going to add the results. So this is going to be the square root of 16 plus 9. Okay, so this is going to be the square root of 25. This is 5. You don't have to worry about the negative version, because this is magnitude, it is a distance, it should be positive. Okay, we'll do the same thing for vector v. okay? To get it, we need to square its horizontal component, that's 2, so 2 squared. We need to square its vertical component of 5, so 5 squared. Add the results, take the square root of the whole thing. Okay, so this is going to be the square root of 4 plus 25. This is going to be the square root of 29. Okay, I'm not going to simplify it. Okay, at this point, I can plug in to my formula. Okay, so I'm going to come over here. Let me use a different color. So I'm going to come over here. Okay, the cosine of theta, we don't know what theta is. We're looking for it. Okay, so it's going to be equal to the dot product u dot v. That's -7. You have to use the negative sign. Okay, over the magnitude of u, that's 5, times the magnitude of v, which is the square root of 29. Okay, so if you want theta, theta is trapped on the left side by the cosine, so you have to take the cosine inverse of both sides. So what you're going to get is that theta is equal to the cosine inverse of this quantity, -7 over 5 times the square root of 29. Okay, so we're going to go to our calculator and we're going to get an approximation for theta, and we do need to round to 2 decimal places according to the directions. Okay, so if we go to our calculator, we're going to punch in the cosine inverse of that quantity. If you want your angle returned in degrees, make sure you're in degree mode. If you're in radian mode, you're not incorrect. You're just returning an angle that's in radians. Okay, so we're going to do -7 divided by, make sure if you have an older calculator, the entire denominator is in parentheses. This is going to be 5 times the square root of 29. Whoops, I hit the wrong thing. Let's try this again. So 5 times the square root of 29. Okay, so it should look like this. Okay, cosine inverse of -7 over 5 times the square root of 29. I'm in degree mode, so out will come an angle in degrees. Okay, so here it is. Okay, just from my rough sketch, okay, I expected an obtuse angle closer to 90 degrees than 180 degrees. So this looks like, this makes sense. Okay, so we're going to say this is 105. We need to round to 2 places after the decimal point, so we'll say 0.07. Okay, so 105.07 degrees. Okay, so that's it. That's how you can compute the angle between 2 vectors.